Alright, so I've made a set of free response questions that are a lot like the ones I'm assigning you for this week, and you can use these as examples. I tried to make them match in the ways that they may be challenging or difficult to understand. This week we're focusing on limits, and we're focusing on a little bit of integrals. So let's go ahead and take a look at what we have here first. So this, just like on your guys' set of FRQs, you have a graph, a function that's called f of x. You have a table of g of x with its derivatives in place. And then we also have another function down here, the h function, which is given to us as an equation. So let's read the directions here. It says the function f of x is a graph of 3 line segments. And then we have a differentiable. That's kind of important. If a function's differentiable, then it's also continuous. We have a differentiable function g of x, and its derivative, g prime, are given in the table above. Now the next part's also a little bit interesting. Good thing to pay attention to for something coming up a little bit later. It says the function g of x is decreasing for all x that are less than negative half. So for all values of x that are less than half, the function is decreasing. You can tell that in the first place because the output values are getting lower, and also because the slopes are all negative. However, when you're dealing with tables, if I hadn't told you that it's decreasing for all values of x less than a negative half, you can't really assume that. Just because it decreases, for instance, from 56 to 30, as we go from -8 to -6, that doesn't mean that maybe it didn't go up and then down to 30, right? So when you're dealing with tables, it's kind of important that that extra information is there sometimes. So clear all that out of there. But now we'll go ahead and begin the question number 1 here. It says, determine if the piecewise function given below, which is called j of x, is continuous. All right, so before we begin, we have to talk about how you can tell if a function is continuous or not. A function is continuous if the limit of the function exists, and if the function is actually defined at that point, and if those two things are equal to each other. So it has to be all three. And when you're dealing with a piecewise function, to do this part here, a lot of times, if you're trying to prove that the pieces connect, you have to prove that the limit of your function as you approach C from the left is the same thing as the limit of your function as you approach C from the right. Because we have two pieces in a piecewise function and they are joined at x equals 2. The question is, do those two pieces actually connect? In other words, is the limit from the left the same as the limit from the right? If those things are true, then the limit exists. So, to do this particular problem that we're looking at right here, bring those back real quick. To do this problem, to prove that this function is continuous, first thing I'm going to do is I'm going to prove that I'm going to find what the limit is from the left of 2. And then I'm going to find what the limit of the right of the function is, 2. And if those two things match, then we can say the limit exists and that's what the limit is. If they don't match, we're going to stop and we're going to say the limit doesn't exist because they weren't equal. But let's just say they do equal each other. If they do equal each other, the last thing we got to do is we got to see, does the function actually exist at the point that we care about? And if it does exist, we have one more thing to do. We want to see, does it actually equal the limit? Okay. So there's a couple of ways a limit could fail to exist. One way is if the function doesn't exist. Another way a function could not be, I think I might have said that wrong. there's a few ways a function may fail to be continuous. One way is if the function doesn't exist. Another way is if the limit doesn't exist. One way the limit can fail to exist is if the limit from the left and the right are not the same. But even if both the limit exists and the function exists, if those two things are not equal in the end, then it doesn't exist. So there are those three things that we have to test in order to do this. So let's go ahead and begin. I think I'm going to go ahead and start with, first of all, looking at the fact that determine if the piecewise function is continuous for all x greater than 0. And just so you guys know, the reason I chose all x to be greater than 0 is because of the fact that my h function here is this thing. And as you guys can see, because there's a denominator of x there, x cannot equal 0. And so I figured, okay, so I want to prove this thing's continuous. Now, it's possible I could give you a problem like this without telling you this. In that case, you would still have to check to see if the limit exists and if the function exists at the connection point. But you have to understand that the pieces themselves also have to be continuous as well. But we're not going to worry about each piece separately because I'm just telling you all we care about is where x is greater than 0. And since this is just a line, that's always continuous. And for this function, x can be anything except 0. So long as x is greater than 0, then both of these pieces are always continuous. So we only really need to test one thing then. We just need to make sure that they connect. And that's what we're going to be focusing on in this problem. All right. So the first thing I want to do is I want to see, does j of 2 actually exist? Okay. So let's go ahead and plug this in. If I plug in 2 to the j function, the first question is, which piece do I use? Do I use the top piece or the bottom piece? Where can x equal to? We're going to use the top piece. The reason I'm going to use the top piece is because this is the one that says x can actually be equal to 2. So j of 2 is the top when you plug 2 into it. So j of 2 is h of 2. So I'm going to take what h is now, and I'm going to plug 2 in for x. All right. So 8 divided by 2 is 4. And then we have e. 3 times 2 is 6. Take away 6 is 0. Anything to the 0 power is 1. Cross that off and I'll put a 1 there instead. And 4 times 1 is 4. So there's that. So we have our first criteria there, that j of 2 actually exists. J of 2 is 4. Now I want to see, does the limit exist for this function? Does the limit exist for this function? Well, the way we're going to see if the limit exists for a piecewise function, if both of the pieces are continuous, which we've already discussed, they are, on this interval anyway, we just need to make sure that they actually connect. And if they do connect, then it's continuous. So the question then is the limit of j of x as x approaches 2 from the left the same thing that we would get as the limit of j of x if we approach 2 from the right? Okay, so now let's start with this one here. If I'm approaching j of x, if I'm approaching 2 from the left, well, if I'm approaching 2 from the left, that means I'm approaching 2 from numbers that are smaller than 2. Which of these pieces represent where x is smaller than 2? Well, it's the top. X is less than or equal to 2. So for this piece on the left here, we're approaching 2 from the left. For j of x, that's the same thing as approaching 2 for h of x from the left. Now for this one over here on the right, I'm approaching 2 from the right. I'm approaching 2 from the right, that's the bottom piece. So approaching 2 from the right with the function j of x is going to be approaching 2 from the right with the expression negative. Okay. Now, at this point, the only number we're not allowed to didn't want to do that. The only number we're not allowed to directly plug in to h is 0. As we mentioned before, if you try to plug 0 into this, you'll get undefined. So I'm allowed to plug in 2. So the way I'm going to find this limit here is just by direct substitution, h of 2, which we already did when we found what j of 2 was. We found out that that was 4. So let's go ahead and do the other side. This is also a direct substitution problem. I can plug in 2 there. As you guys can see, they're both 4, but they're not the same. One's positive, one's negative. So the limit from the left and the limit from the right are not equal to each other, and therefore the limit does not exist. Now you would still have to show all your work that I've been writing here, right? But here's how perhaps I would write my answer on an FRQ. I would say, okay, well, j of 2 equals h of 2, which is equal to 4. I don't think you really need to show your work for where we plugged in 2 here, because that's something you can actually do mentally, but it can't hurt to show your work. We did that earlier. Then the next thing I would show is I would show this. And this demonstrates for us that therefore the limit of j of x as x approaches 2 does not exist. So therefore we would say no, it's not continuous. So how would you be graded on this thing? For 2 points. So I would think that in one case you would have to, 1 point would be in showing that you found what j of 2 was. The other point would be in showing what you got for the limit. And both of those should support your answer. So just so you guys know, even though I'm giving a point here and here, let's say you wrote this, but then you wrote that it is continuous, well, you would lose at least 1 point for giving a wrong conclusion. But if you have both of these correct and you state that it's not continuous, then you okay. So 1 point for finding what the function equals, 1 point for stating what the limit is, and then drawing your conclusion. Now, just so you guys know, technically, if you're dealing with a problem where you actually do have a limit, you would have to do one more statement. You would have to say, and let's say you found that j of 2 was 4, right? And let's just say we found that the limit of j was also 4. You would have to say, and therefore j of 2 equals the limit of j as x approaches 2. Therefore, yes. Okay, so you'd have to state that as well, that they're actually equal. But in our case, we'll stop a little bit earlier than stating this final fact and just say, well, no, it failed because the limit didn't exist. All right, so there's that. Let's go ahead and move on to our next question here. It's going to be number 2. All right, so for number 2, this thing is stating for us that it's asking us to find for which values of x is f of x not continuous. Now, when you're looking at a graph, f of x, that's kind of easy, in my opinion, because you just look at the graph and you look for where there's any holes, gaps, or jumps. So I've got one right here, and I've got one right here. Those are my 2 places where it's not continuous. I've got a hole, a gap, a jump, or an asymptote of some kind, right? So we have 2 places where it's not continuous. We would say it's not continuous at x equals -6, and it's also not continuous when x equals -4. But they're going to have some slightly different reasons. Okay, now what are some ways that a function may fail to exist? One way is if the function doesn't exist. In other words, there's just not a point there. Another way that it would not be continuous is if the limit doesn't exist. And the final way it could fail to not be continuous is that even though the function exists and even though the limit exists, those two things fail to be the same. Okay, so we have two situations here where we can tell just by looking at the graph that it's not continuous, but we have to accurately state why it doesn't exist at those particular points. So let's take a look at the -6 up here first. This one. So, does the function exist at that point? The answer is no. So what we would say is that f of -6 does not exist. That would be our reason for why x equals -6 does not exist. How about for x equals -4? All right, well, for x equals -4, the function does exist. And just to, this part you would not write, but just kind of pay attention here. There's an answer for this. F of -4 exists. It's up here. F of -4 is 1. So that's not why the limit fails to exist. How about the limit? Does the limit exist? The answer is yes. The limit does exist. I'll show you. Once again, you're not going to write this part. You're just gonna look at it with me for now. Why does the limit exist? Well, remember, a limit just means what is the function approaching? And so long as it's actually approaching one number, then the limit exists. So as you guys can see here, as I approach -4 from the left, it's approaching this spot, which is y equals -2. And as I approach it from the right, it's still approaching -2. So since it's approaching the same point from the left and right, -2, then we say that the limit exists, and the limit therefore would be -2. But here's why the function is not continuous. The reason the function is not continuous at -4 is because even though f of -4 exists, and even though the limit exists, the problem is they're not the same. F of -4 is 2, wasn't it? Oh no, it was 1. Sorry about that. F of -4 was 1, and the limit was -2. Those are not the same. So those are our explanations there. All right, let's move on to our next question. Oh, by the way, how would you be graded on this? This is once again a 2-point question. You would get 1 point for correctly identifying the locations, and you would get your other point for correctly stating your reasons why each point was not continuous. And to get that point, you'd have to give both statements. All right, let's move on to number 3. All right. So find the limit of this weird looking expression and then justify your answer. Okay, well, the first thing we do anytime you're trying to find a limit is you're going to try direct substitution first. So let's do that. We're going to just plug it right in. We're going to plug in 2 for x everywhere we see an x. Okay, now first of all, let's find out what g of 2 is. G of 2 is 6. 3 times 2 is 6. And we already found that g of 2 is 6 once again. Now we need to find f of 6. What is f of 6? So now we got to look at our f function, find where f equals 6. That's right there. And the outcome is 0. So what we end up with then is 0 over 0, but I'm not going to put equals 0 over 0. I'm going to say yields 0 over 0. You guys remember when we talked about this a while ago, this is what's called an indeterminate form. Indeterminate form. You cannot say that this equals 0 over 0 because 0 over 0 is not a number, so therefore this cannot equal that. Equations are for things that are actually equal to each other, so we don't write that. Instead, what we're going to say is direct substitution, this whole stuff here, yields 0 over 0, which is an indeterminate form. But hope is not lost. When you're trying to find the limit and direct substitution gives you an indeterminate form, what you do is you do L'Hopital. So now you would say, therefore, by L'Hopital, the limit as x approaches 2 of g of x minus 3x over f of g of x is the same thing as, gotta make some room here, the limit as x approaches 2 of the derivative of the top and bottom. Okay, so we're going to take the derivative of the top. That would be g prime of x minus 3 over, now this is a composite function, so we do the derivative of the outside multiplied by the derivative of the inside. Okay, that's L'Hopital's rule. So whenever direct substitution gives you an indeterminate form, which could be 0 over 0 or infinity over infinity, we do L'Hopital's rule, which basically says that this limit is equal to the limit of the function where you take the derivative of the top and the derivative of the bottom. Now, before I erase stuff, because I do need to erase stuff for more space, I want to make a statement about what's important. You actually get what you guys actually end up writing on your FRQ. First of all, you would need to state, you could show your work like I did here and then state that it yields 0 over 0. Or you could just say in a sentence, direct substitution yields 0 over 0. You wouldn't necessarily need to show your work because, once again, I think that's technically something you get just by doing mental math, possibly. A little hard, but it's possible. So somehow you need to say that direct substitution results in this, either by showing your work or stating that fact. The next thing you need to do is state this whole thing here. Okay? You need to say, therefore, by L'Hopital's rule, the limit of the function we're trying to find is the same thing as the limit of this, which is the derivative of the top and bottom of our original function. Okay, so those two things are important to have before you go any further. Okay, now at this point, what we're going to do is we're just going to go ahead and do some direct substitution and get our final answer. Make some room here. Okay, so now that we've done that, let's try direct substitution again. This time I'm going to plug 2 into this expression instead of the original one. So if I do that, I'm going to have g prime of 2 minus 3 over f prime of g of 2 times g prime of 2. Okay? And now we just get to kind of figure out what all that stuff is here. So let's do that. Here we go. So g prime of 2. G prime of 2, when x equals 2, g prime is 5. So that's going to be 5 minus 3 over f prime. What's g of 2? G of 2 is 6 times g prime of 2, which we found earlier. We know that's 5. What's f prime of 6? Here's our f graph. Here's 6. Now what's f prime? Remember, f prime, that means the slope of f at x equals 6. So what is the slope of this line at x equals 6? Well, just look at this line. It's a simple straight line, so all you have to do is do rise over run here. It's over 2 up 1. So that's a slope of a half. So I have 5 minus 3 over 1/2 times 5. Now, at this point, I would say just leave your answer because that's good enough. Because nobody, you don't want to risk getting this wrong because of the fraction there. They will give you full credit for that answer right there. However, I'm going to go ahead and simplify it just for fun. I don't know what your guys is like on your, I don't remember if it comes out weirdly. I think it probably comes out a little bit cleaner, but anyway, 5 take away 3 on the top is 2. And on the bottom, 1/2 times 5 is 5 over 2. We talked about how to simplify fractions within fractions. What you do is you multiply the top and bottom of the fraction by the little denominator there. And what you would end up with is 4 over 5 as a final answer. Okay, so there's a lot going on in that problem. First of all, direct substitution gave us an indeterminate form of 0 over 0. Therefore, we applied L'Hopital's rule. And then we did direct substitution with our new L'Hopital expression, and that gave us 4/5. Okay, so 2 points. What would give you 2 points? I would say the first point that I would give for this would be for identifying the fact that you need to do L'Hopital's rule. And the second thing I would give you points for on this is getting your answer. Now, I don't want to oversimplify this and say, on your FRQ, all you have to do is say, oh, I'm going to use L'Hopital. You have to write the things that I told you to write earlier. But that would be worth 1 point, and then the final answer would be worth the last point. Okay? Let's go ahead and move on to our next question. Okay, so number 4, is there a number c on the interval from -8 to -2 such that g of c equals 5? Now, guys, there's different ways this question can look. One way is like this. That's an intermediate value theorem, I believe is what that's called. But if you see a prime there, a lot of times that's a mean value theorem. That changes the game completely. But in this case, it's just g. So we're going to be dealing with the intermediate value theorem. So just to kind of refresh your guys' minds about what that is, basically this means that if a function goes from here to here at some point along the way, doesn't matter how you get there, as it went from that point to that point, if it's continuous, it had to cross some other point in the middle between those 2 points. That's the intermediate value theorem. So if you have a continuous function and it goes from one low value to a high value, then it had to cross any number that you may choose between those 2 values to get there. Now, but understand, it is a stipulation that that only works if it's continuous. If you have a broken function, a non-continuous function, then there are some values in between there that don't actually exist. Okay, but that's what the intermediate value theorem is. Now, first of all, let's take a look at the fact that we're looking at g and we're going from -8 to -2. So I'm going from -8 to -2 and I'm looking at the g function. Now, you don't have to graph this, but I'm just going to do this to kind of help the problem make some more sense. So basically, here's what we're looking at. We're looking at a function of g, and we're going from -856, which I'll put here, and we're landing at -2, +2 here. Okay, and we're going from this point to that point. Now the question is there some value c on the interval from -8 to 2, somewhere in here, is there some place where g of c equals 5? So 5 would be like right about here. So in other words, is there a dot here such that there's a c value in here somewhere where if we plugged it in, we would get 5? And the answer is yes, there is. Now why? It has to be continuous, right? So let me ask you guys a question. Is g continuous? You can't tell with a table. There could be holes, gaps, or jumps, right? But this is a continuous function. Why? They tell you the function's differentiable. Since the function's differentiable, it is continuous. Okay? Now, how do we write this? This is something you want to stick on a flashcard because it's not an obvious thing to remember, but now, honestly, you guys should be able to take everything I just told you and write your own sentence right now. But just to make sure you get all the details in there, I had you guys kind of like, in a way, memorize a sentence so that you don't leave anything out back when you did this. And here's how it went. Ready? Since G is continuous and goes from 56 to 2 on the interval -8 to -2, there must be a C such that, actually, back up a little bit. There must be a C on that interval. You have to state it's on that interval such that G of C equals 5. Okay. And that would be good enough. There you go. Since G is continuous and it goes from +56 to +2 on the interval from -8 to 2, then somewhere on this interval there has to be some value C such that G of C gives me a value of 5, since 5 is between 2 and 56. Okay? So there you go. That's called the intermediate value theorem. All right, so that's number 4. Go ahead and move on to another one. And that's just 1 point. You either get it right or wrong. Number 5. Okay. Number 5 says, use a left-hand Riemann sum to estimate this. Is this an overestimate or an underestimate? I think I forgot to put something in here. 1, 2. Use a left-hand Riemann sum using 3 subintervals is what I meant to put to estimate this. And the question was, is this an overestimate or an underestimate? Now, something that might be confusing to you guys is the way the table is set up. First of all, to do this question, we don't need this column at all. We only need this. The second thing that's confusing, actually, there's 3 things. We're only going from -2 to 8, so we don't even need this bottom half. So get rid of that. But still, we're a little bit confused because of the way this table looks. When we did these problems, you guys, our tables were all vertical. Okay, so just to make things easier, I'm going to rewrite my table, but if you don't need to do that, please don't. It's kind of a waste of time, honestly, if you already know how to do it. But here's how our tables look when we did these problems before. We put X here, we put the G here, and we wrote our tables out like this instead. So we wrote our tables like this. That might help you understand the process a little bit better, but you totally can do that up here if you just kind of pay attention to the details. But I digress. Let's go ahead and continue. It says, use a left-hand Riemann sum using 3 subintervals. Oops. I erased more than I wanted to there. Okay, so we're going from, the first thing we do is we found the base of each rectangle. That's way too wide. How did that happen? It goes up by 2's for me. We have 3 2's. Those are my bases. And since we're doing a left-hand Riemann sum, we start on the left. That's my first height. Here's my second height. Here's my third height. we don't use the last one. So we have 56 times 2, which is 112, plus 30 times 2, which is 60, plus negative 12 times 2, which is negative 24. And that is what the integral from, I think I wrote that backwards, negative 8 to negative 2, the g of x function, would look like. And you don't have to simplify it if you don't want to. Again, as long as you have that, you're good. But I'm going to go ahead and do it anyway. 112 plus 60 minus 24 is 148. Final answer. Okay. 2 points. So that's the first point. The second point is to explain to me whether this is an underestimate or an overestimate. So what we talked about a little while ago was that whether a function is an overestimate or underestimate depends on two things. It depends on whether the function is increasing and decreasing, and whether you're doing a right-hand sum or a left-hand sum. Now in this case we're doing a left-handed sum. So if I start on the left and I draw my rectangles, they would all be underestimates. But if it's a decreasing function and I start on the left, the rectangles will give me an area that's above the curve, and so we would end up with an overestimate. So it's under if it's increasing, and it's over if it's decreasing. Now be careful though. It's the opposite if we're doing a right-handed sum. But in this case, if your function's increasing, it's under. If it's decreasing, it's over. So I'm doing a left-handed sum. And what is my function doing on the interval from negative 8 to 2? Well, it's kind of dangerous just to assume that it's decreasing by looking at the y values, even though it is. And it's still even a little bit dangerous to tell if it's decreasing by looking at the slopes. They're all negative, therefore that looks like it's decreasing. But tables are tricky because they don't really give you all the data. So who knows, maybe somewhere on that interval it switched, right? But that's what this was for. They told us that for all x less than a negative half, which means all of this here, the function is decreasing. So we know it's decreasing. We're doing a left-hand sum, therefore it's an overestimate. So we would say, as our explanation, since g is decreasing on the interval negative 8, negative 2, a left-hand sum is a overestimate. I'm kind of running in space, so it's an overestimate. But there you go. All right. So that would be the second point, giving me the explanation about whether that is an underestimate or an overestimate. And once again, guys, be cautious. Make sure you are showing your work as you do these problems. You do not get credit for just blank answers. Okay. All right, I think we're on number 6 now, if I'm not mistaken. This one's worth 1 point. This is actually a repeat question from last week's extra credit. But I like to put these in here because a lot of times students get these two types of questions mixed up. So it looks exactly like the last question I did, but there's a slight difference. Do you guys see what that difference is? There's actually two differences. One is it doesn't say estimated. When you're doing Riemann sums, those are estimates. The area under the curve, they're not actual values of the integral. So it's not estimating. So in this case, it doesn't say estimate. So whatever we're going to find, it's actually the answer. The second difference is that it's a g prime. It's not just a g anymore. In this case, here's how I would handle this. We would integrate g prime. What is the integral of g prime? It is g of x. An integral cancels out the derivative. And we're going from negative 8 to negative 2, which means g of negative 2 is being subtracted from g of negative 8. And from there, we just use our table. G of negative 2 is 2, and g of negative 8 is 56. And so the final answer here would be negative 54. So they're completely different. They look very similar, but they're actually completely different. So I figured I'd put that in there, even though it's a repeat question from last week, because they look so similar, but they are very different. Next thing I want to draw your attention to is only 1 point. So it's all or nothing. You had to show your work, but it's all or nothing. All right. Next thing we're going to look at, number 7. And just so you guys know, in FRQ, I don't know what they're going to look like this year since they're doing things a little bit differently this year with the pandemic. But usually FRQs only have, 4 questions each. I'm definitely overloading these with lots of things so that you guys get a lot of exposure to different stuff. But all right, let's go ahead and take a look at number 7 here. So I give you a new equation called the y function, and the y function is h minus 3 times the g function, and they want us to find y prime of 2. And so we're just practicing some derivative properties here. So if I want to find y prime of 2, the first thing I need to do is I need to find y prime. So the derivative of y prime is going to be the derivative of that, h minus 3 times the derivative of g. That's simple. And if I want to find y prime of 2, then I need to find h prime of 2. Okay, now this one's going to cause some trouble for us. We'll do that one next. But let's start with the easy one. 3 times the g prime of 2. G prime of 2 is pretty easy. That's just 5. So we have y prime of 2 is equal to h prime of 2 minus 15. Now we get to focus on this for a minute. That's going to, like I said, that's going to be a little bit of a stretcher for you guys. It's going to really test your ability to do derivatives well. What is h prime of 2? Well, what is h? H is this equation that we have up here, right? So if I want to find h prime of 2, the first thing I got to do is I got to find h prime of x. How do I do that? Well, this is a product rule. We have this being multiplied with this. So we're going to do the product rule. A times b plus a times b. Okay? Now to begin, before I start applying my product rule, I'm going to rewrite this stuff a little bit to make it a little bit easier to deal with. Instead of writing that as 8 over x, I'm going to rewrite it like this. I'm going to call that the a, and then of course we have this. So here's how it works. I'm going to call this piece here a, and I'm going to call this piece here b. So the product rule is a, b, prime here, and if you did our extra credit last week, all this is like, oh yeah, we just did that, not too bad. If you didn't do our extra credit last week, you probably forgot about it. But anyway, here we go. Let's go ahead and find the derivative of a first. All right, so the derivative of 8x to the negative 1 power. So we're going to multiply negative 1 to the front. That's going to give me a negative 8. And then we're going to take 1 away from the power, which will make it negative 2. So now I'm just going to put it back down at the bottom as an x squared. Next, we're going to put b in there. b is 3x minus 6. Next, we're going to write a, which is 8x to the negative 1. Since we're not doing anything with it, I'm just going to put it back the way it was, 8 over x. But for b prime, when you take the derivative of an exponential function with a base of e, you always just get the original function as it was, but you have to multiply it by the derivative of whatever the power is, and the derivative of that is 3. Okay? Now I want to find what is h prime of 2. So I'm going to be plugging in 2 here. So I have negative 8 over, if I plug in 2 here, I'm going to get 4 times, if I plug in 2 here, I'm going to get 3 times 2 minus 6, which is 0, and e to the 0 is 1, plus, plug 2 in here, I get 4, 8 divided by 2 is 4, times 3, times, if I plug in 2 here, I get 1, And actually, to save space, I'm just going to go ahead and erase this now. Negative 8 divided by 4 is negative 2. And so we end up with negative 2 plus 12, which is 10. So there's my answer for h prime of 2. That was a lot of work. 10 minus 15, which means that y prime of 2 is negative 5. Okay? So that's the end of number 7. You get 2 points for this problem. Believe it or not, I would say that 1 point would be very simple to get. The first point would just be doing this, demonstrating that you understand the property of laws, or I'm sorry, not laws, of derivatives. That would be 1 point. The rest of the point is everything else we did, which is just plugging in the 2 and getting these answers and simplifying it. But that was a lot of work. All right, let's move on to the next one. The next 2 questions are kind of similar to this, just doing a bunch of derivatives and making sure you know the properties well. Number 8. 2 points as well, once again. Just doing the basic derivative is first and then plugging it in to get the answers after that. All right, so here we go. Z of x is this quotient function now. They want us to find z prime of 4. So the first thing I need to do is I need to find out what z prime of x is, and that'll be my first point. So since it's a quotient, we're going to do the quotient rule, which is low d high minus high d low. Line, square below. The next step is just to plug in the 4. So z prime of 4 is going to be f of 4 times g prime of 4 minus g of 4 times f prime of 4 all over f of 4 squared. All right. F of 4, we're going to look at the f graph. F of 4 is right here. That's a value of negative 1. G prime of 4, 9. G of 4 is 18. Parentheses. And then f prime of 4, that means what's the slope of the line there at x equals 4, and it's the same thing it was earlier. It's over 2 up 1, so it's a half. Over f of 4 squared. F of 4 we said earlier is negative 1. So what we have here is negative 9 minus 9 over 1, which is negative 8. So you get 1 point for just writing this, 1 point for getting to your final answer. But once again, you can't just have answers pop up out of nowhere. You need to show your work. All right, last FRQ example for you. Number 9. All right, same rules for getting points here as doing the derivative. And then second point is for plugging it in and getting the answer. So they want us to find w prime of 2. So to do that, we need to start by finding the derivative of w. So we start by taking the derivative of this. Now that's a chain rule. It's the derivative of the outside. Change the inside. Times the derivative of the inside. Minus, this is also a chain rule. We have g of x to the 3rd power. Okay, so what that means is the inside function is the g of x, the outside is the cube. So we take the 3, we multiply it to the front, and we take 1 off the power, and we don't change the inside. And then we do multiply it by the derivative of the inside. So 2 chain rules there. Next, we're going to go ahead and plug in our 2. Okay. Well, let's go ahead and start working some of this stuff out. So G prime of h of 2. Let's do this first. What is h of 2? Well, we did that earlier. We plugged it in up here, and I believe we got 4. Let's do h prime of 2. Ugh, gosh. Did we do that earlier? Remember now. We might have to do that again. I think I'll leave that there for now. We'll come back to that. Finding that derivative was kind of a pain in the butt, in case you don't remember. The next one here, we have 3, and then we have g of 2 squared. G of 2 is 6, so 6 squared is going to be 36. And then g prime of 2 is 5. So let's go ahead and keep going here. I can do this one. G prime of 4 is 9. And this is a pretty hefty... Oops. Just a minute, having some technical issues. Okay, so I'm going to do all these multiplications over here. 36 times 3 times 5, and I'm getting 540. So now we got to do this before we can go any further. A little bit earlier, we found the derivative of h. I'm going to write that out again. You guys probably already have it on your paper. I have to rework it here a little bit. But here's what we had, I believe. We had negative 8 over x squared, e to the 3x minus 6, and then plus 8 over x times 3 times e to the x minus 6. And this time we're plugging in 2. So if we plug 2 in here, we're going to get 8 over 4, which is negative 2. Plug into, I think it is the same answer we had last time. Oh well. 8 over 2 would be 4 times 3 times 6. I don't know. It does look a little bit, oh, not 6. So we have 12, yeah, we did that earlier. It's 12 take away 2, which is 10, so. So 90 take away 540 is going to be negative 450. So once again, you get a point for just showing me what the derivative of this is. The second point is for actually the final answer. And that's the end of your derivative review. Move on to the other part.